Hi everyone, today we are going to continue with Unit 13 and we're going to look today at how to translate sine and cosine functions. So we can translate these periodic functions both horizontally and vertically, similar to how we've translated other functions. You might see this word phase shift thrown around. What that means is a horizontal translation, only horizontal. Vertical translation is just called vertical translation. I'm not 100% sure why we have a special name for a horizontal translation, but that's called a phase shift and versus a vertical shift. Now you can see down here that when we translate this f of x function left or right, it looks like we were translating it to the right. We used minus h to show how many units we shifted to the right. Over here, we used plus k to show how many units we translated or shifted upwards. Now, this should look familiar because we've got minus h and plus k. And we've been looking at things like we did with exponential functions, for example. We would have, like, for example, we could have y equals 2 to the x minus 1 plus 4, and that meant shift right 1 plus and up 4. Same idea here. If it's inside the parentheses, change the sign and move it this many units. So in this case, it'd be moving right however many units. If it's outside the parentheses, we just move it up or down depending on what the sign is. The sign stays the same. And we did this with logarithms. We even did this with parabolas. This is not a new thing. It's just applying it to the periodic functions. So describe the phase shift. If I had this function right here, I would say, okay, it's in the parentheses. There's a minus sign, so that means that I would change it and I would move right 5. Here, I would change the sign, so I would move this one left 3. And that's it. Just remember to change the sign when it's inside the parentheses. So if we're graphing a translation, it's going to be similar to what we've done in the past. We're going to sketch the parent function and then graph the translation. So for example, if we had the function y equals sine x plus 3, and then minus 2, I would graph the parent function, which would be this part here. It would be the graph without anything added or subtracted. Another way to think about it is I'm going to draw a line right here and graph what comes before it. And then after I've graphed it, I can shift the function left 3 units and down 2 units. All right, so here we would have plus pi inside and we have minus 2 outside. Actually, let me do this. So the thing that's outside is a vertical shift, and we keep the sign, so that's going to be down 2. The thing that's inside is going to be opposite sign, so we move. So the phase shift is going to be left pi, and that sounds weird, but remember, on a lot of times on our graph we have like pi, 2 pi, and so we would be shifting everything left pi units. For this next one, we've got this here, so that would mean that our phase shift would be right pi over 2, and I don't know where my pens went. The vertical shift would be down, or no, sorry, up. We keep the sign, up 1. That's it. Right. So, there they are. Maybe not. Maybe not. All right. Sorry, guys. So it says to sketch the interval from 0 to 2 pi. And so what I'm going to do is I'm going to say, what is my parent function? Well, it is this part right here. It's the graph without anything added or subtracted to it. So I'm just going to graph this like we've been doing up till now. I'm going to say, okay, what's my amplitude? Well, my amplitude is 1. There's nothing in front of the sign. What's my period? And my period would be 2 pi over b, which is 3. So what this means is that we have one cycle between 0 and 2 pi over 3. Now normally I've been graphing like this and putting 2 pi and then pi and pi over 2, but this time I'm going to do something a little different. Because I have this period of 2 pi over 3 and it's between these two values, 2 pi over 3 then would be somewhere between pi over 2 and 3 pi over 4. I actually want to go ahead and count by thirds instead of by fourths, just so I can graph this accurately. So I've got 0 here, and then I'm essentially taking each of these, and before I was saying this is 1/4, 1/2, 3/4, 1, and breaking it down into quarters. Now I'm going to break it down into thirds, so that's going to make this be pi over 3, and 2 pi over 3, and this is pi. If you want to label all of them, you can. You need to have at least like the 2 pi over 3 on there. The more labels you have on there, the better. It would not be enough just to have 2 pi on there. All right, so it's a sine function, so that means it starts at 0. Actually, let's pick a different color. Starts at 0 and ends at 2 pi over 3. My amplitude was 1, so I'm going to put that right here and right here. So that means that my midpoint, where it crosses back over, because it has this shape, is going to be at pi over 3. And halfway between those is where it's going to hit its maximum and its minimum. So there's one cycle. However, this has to graph from 0 to 2 pi, so I need to continue this pattern all the way out to 2 pi. So I'm just going to continue with that same pattern. And what I should see is that every 2 pi over 3 units, I have one complete cycle. There we go. Not perfect sketch, but that's pretty close. So that's how we would do that. But now we have this plus 1/2 to deal with. So this plus 1/2 here is not in any parentheses, so this means that we are shifting everything up 1/2 units. So I'm going to take each point from the graph and move it up 1/2. And I'm just going to shift everything. What you could do if you don't like having your points in the middle of the, like in between 0 and 1, for example, excuse me, I could have graphed 0, 1/2, 1 and counted by 1/2, and that would make it so that it looks a little bit, maybe a little cleaner. But really, ooh, kind of lost it there in the middle, but it's a no judgment zone. What it should do is keep the same shape and just shift everything up 1/2. Every single point gets moved up 1/2, and I do need to see all these points on here. It shouldn't just look like this. That is not an acceptable graph. All right, so my parent function here is going to be this. Even though that x is in the parentheses, it's just because we've got something added at the end. It's still part of the cosine. So I've got amplitude of 1, period again of 2 pi over 3. So I'm going to oops, let me put that lower. I'm going to count by thirds again. So it'll look just like the last one. 4 pi over 3, 5 pi over 3, and 2 pi. And then now I'm starting at cosine. So since I'm starting at cosine, I'm still going to count by ones like this. Instead of starting at 0, I'm starting at 1. So I'm going to go up here, and that's my starting point. And again, this means that between 0 and 2 pi over 3, I have one complete cycle. So I'm going to put my starting point on theta equals 0, and my ending point at 2 pi over 3, but it should be at the same point as where I started. Now, halfway between those this time is the minimum, the opposite of the maximum. And then halfway between those is where it crosses the the theta axis. Let's see, so that's going to look like that. And then I'm just going to continue that pattern so that it goes all the way to to 2 pi. All right, there we go. Actually got better as I went. So we need to now look at this and say, okay, the shift that's happening is to shift everything left pi over 2. And this one's going to get a little tricky because we put our graph in terms of thirds instead of halves. So we're going to have to do some estimating. What I know is that 1/2 is greater than 1/3. So when I'm shifting everything left, it's not enough to just shift this point to here because that would only be shifting 1/3. I need to go a little bit past that. And usually what I do is I start at one end of the graph, either the left or the right end, and I just kind of find where does that go, and then I shift each of the points after that. So remembering, you could even, if it's easier, find each of the points that are like on the grid. Like this point is not on the grid, it's halfway between them. This one is, so I could go 1/3 and then a little more as a half, and then find the midpoint. I'm not going to be too picky about it, but it should be very clearly, like if you just move this point from here to here, that is only moving it 1/3. We have to move it 1/2 or pi over 2. So I'm using kind of that method of the midpoints. Finding the midpoints. And then this one is going to go off the graph, but that's okay. And then this one's going to go here, midpoint, midpoint. Okay. All right. So this would be a good sketch. I can see that I shifted it. Honestly, it's hard to tell if I shift it left or right because of the pattern repeating, but here we do know that we shifted it left because we made sure that we went through and shifted left.